In the autumn of 1944, a captured German infantry officer was presented to Allied interrogators at a processing facility somewhere in northern France. The man was a veteran. Eastern Front, North Africa, Normandy. He had fought against the British, against the Russians, against the Free French. The interrogating officer asked him a single question. What was the most significant tactical advantage the American infantryman possessed in the field? The German officer did not say air superiority. He did not say logistics. He did not say numbers. He said the rifle. He said that in a standard firefight engagement, 2 squads, open ground, 50 to 100 meters, an American squad produced approximately 2.5 times the volume of accurate outgoing fire as a comparable German unit. Not because the Americans were better marksmen, not because they were better soldiers, because their rifle fired 8 rounds semi-automatically, without requiring the shooter to break his firing position. The German's rifle, the Carabiner 98K, required the shooter to manually cycle the bolt between every single shot. Lift, pull back, push forward, lock down. Here is what makes that testimony remarkable. The M1 Garand was not a new invention in 1944. It had been in development since 1919. It had been the standard US Army infantry rifle since 1936. By the time that German officer was captured, America had already manufactured more than 3 million of them. And yet, despite a development cycle of nearly 2 decades, despite being the most studied and most refined semi-automatic infantry rifle ever produced, the M1 Garand very nearly never happened at all. It was rejected twice by the same institution that eventually adopted it. The man who designed it spent 14 years fighting a bureaucracy that did not want what he was building. And when the rifle was finally approved, the production system built around it was so sophisticated, so precisely engineered, that it became as consequential as the weapon itself. This is not a story about a gun. This is a story about a system, and about the extraordinary series of industrial and institutional decisions that turned a rejected prototype into the rifle that redefined infantry warfare. To understand the M1 Garand, you have to understand the problem it was designed to solve. And to understand that problem, you have to understand what a bolt-action rifle actually costs a soldier in combat. The Carabiner 98K, Germany's standard infantry rifle throughout the entire war, was a precision instrument, accurate to 800 meters in trained hands, superbly engineered, mechanically reliable in conditions that destroyed lesser weapons. It was also, by design, a single-shot weapon. Not because German engineers lacked the capability to build a semi-automatic, They had working semi-automatic prototypes by 1935, but the German Ordnance Office made a deliberate decision: precision over volume. The thinking was that a well-trained rifleman with a bolt action needed only 1 round per target. Volume of fire was a profligate American habit. German doctrine emphasized the shot, not the magazine. That doctrine would cost them the war. John Garand, known universally as John Garand, was a Canadian-born machinist who joined the US Springfield Armory in 1919. His brief was simple: design a semi-automatic rifle that could replace the bolt-action Springfield M1903 as the standard US infantry weapon. He spent the next 17 years doing exactly that. The core engineering challenge was gas operation. When a cartridge fires, it produces a large volume of expanding gas. A semi-automatic mechanism captures a portion of that gas through a port in the barrel and uses its pressure to cycle the action, extract the spent case, compress the return spring, chamber a fresh round, and reset the trigger. All of this happens in a fraction of a second, faster than any human hand could operate a bolt. The challenge is that the gas system must be calibrated with extraordinary precision. Too much gas pressure, and the action cycles too violently, battering components and eventually destroying the weapon. Too little, and the action fails to cycle, producing a malfunction in the worst possible moment. Garand's solution was an N-block clip system. 8 rounds loaded into a stamped steel clip, the entire clip inserted as a single unit into the magazine. When the last round fired, the clip was automatically ejected, producing a distinctive metallic ping that has since become one of the most recognizable sounds in American military history, and the bolt locked open, ready for immediate reload. 8 rounds, 1 motion, ready to fire again in under 3 seconds. In 1929, Garand submitted his first working prototype for Army trials. It was rejected. The primary objection was not mechanical. The rifle performed adequately in testing. The objection was doctrinal. Senior Army ordnance officers argued that a semi-automatic mechanism was an invitation to ammunition waste. Soldiers would fire too fast. Supply chains would collapse under the volume of expenditure. The Army's established doctrine of aimed, deliberate rifle fire, 1 round, 1 target, was sound. A weapon that encouraged spray firing would degrade marksmanship standards across the entire infantry. These were not irrational concerns. They were, however, wrong. They were wrong because they evaluated the rifle as an individual weapon, rather than as a system component. They asked, what does this rifle do to a soldier's marksmanship? They did not ask, what does this rifle do to a squad's aggregate fire volume? What does it do to a fire team's ability to suppress an enemy position while a flanking element maneuvers? What does it do to a platoon's ability to generate overwhelming fire at the moment of contact? Those are systems questions. The Army would not begin asking them seriously until 1936. In 1932, Garand submitted a revised design. It was rejected again. This time because the Army Cavalry Branch objected to a rifle that could not be easily operated on horseback. The United States Army Cavalry, in 1932, objecting to an infantry rifle on the grounds that it was incompatible with mounted operations. The irony requires no elaboration. The rifle was approved in 1936, designated the U.S. Rifle, caliber .30, M1, after General Douglas MacArthur intervened personally in the ordnance selection process. MacArthur had observed the performance of semi-automatic weapons in field exercises and reached a conclusion that would prove decisive. The volume of fire a unit could generate per man was as important a tactical variable as the accuracy of any individual shot. Fire superiority, the ability to force an enemy into cover through sheer volume of incoming rounds, was itself a combat multiplier. He was right, and the decision he forced through the ordnance bureaucracy in 1936 would not be fully understood in its consequences until the hedgerows of Normandy. The approval of the M1 Garand as the standard US infantry rifle is not the important part of this story. The important part is what happened next. Because the United States Army in 1936 did not simply adopt a weapon, it committed to manufacturing that weapon at an industrial scale that no military in history had yet attempted for a semi-automatic infantry rifle. And in doing so, it created a production system of such sophisticated precision that the rifle itself became almost secondary to the infrastructure built to produce it. The Springfield Armory in Massachusetts was the primary production facility. It had been manufacturing military weapons since 1794. It knew how to make rifles. What it did not know, what no one knew, was how to make this rifle at the volume the Army now required. The M1 Garand contains 63 individual components. Each component must be manufactured to tolerances measured in thousandths of an inch. Each component must be interchangeable, meaning a trigger group from a rifle made in 1942 must fit and function perfectly in a receiver made in 1944 at a different facility by a different worker who has never seen the original assembly. Interchangeability. It sounds obvious, It is not obvious. It is one of the most difficult engineering and manufacturing challenges in the history of industrial production. The challenge of interchangeability had nearly destroyed American weapons production during the Civil War. Parts made to nominally identical specifications at different facilities, or even at different machines in the same facility, often failed to interchange because the measuring instruments used to verify the parts were themselves not calibrated to a common standard. The result was weapons that could only be assembled from the specific batch of parts they were made with, and that could only be repaired using parts sourced from that same batch. In a war, in a field, with no parts batch records and no logistics chain refined enough to track component provenance. The Springfield Armory solved this problem through a system of gauge blocks, precision-machined steel blocks calibrated to known physical constants that provided a universal measurement reference across all production lines, all facilities, all shifts, all workers. Every single component of every single M1 Garand was verified against these gauge standards before it left inspection. If a part did not pass gauge, it was rejected. Not reworked, rejected. This sounds wasteful. It was, in fact, the opposite of wasteful. It meant that every part that reached assembly was guaranteed to be correct. It meant that every rifle that left the armory was guaranteed to function. And it meant that every spare part that reached a field depot anywhere on Earth was guaranteed to fit any rifle that came in for repair. The system cost more per unit to operate than a production line with looser tolerances. It produced fewer defective rifles per 1,000 manufactured. The arithmetic was not close. When America entered the war in December 1941, the Army held approximately 800,000 M1 Garands in inventory. They needed 10 times that number. Springfield Armory was already at maximum production capacity. The Army turned to the private sector. Winchester Repeating Arms Company received a contract to produce M1 Garands in parallel with Springfield. The challenge was that Winchester had never made this rifle. Their engineers had to reverse engineer the production process from the weapon itself, understanding not just the dimensions of each part, but the sequence of operations, the tooling required to achieve the tolerances, the inspection protocols to verify compliance. Winchester completed this process in 90 days from contract to first production units, for a weapon of 63 components requiring tolerances measured in thousandths of an inch in a factory that had never produced it. By 1944, Winchester and Springfield together were producing over 100,000 M1 Garands per month. The total wartime production figure across all contractors would reach 5.4 million rifles. 5.4 million. Semi-automatic, interchangeable parts, gauge verified to within 1,000th of an inch. Every one of them. To understand what 5 million M1 Garands meant On a battlefield, you have to understand the mathematics of infantry firefighting. In a typical small unit engagement, a squad of 12 men engaging an enemy position at a range of 100 meters, the decisive variable is not accuracy. At that range, any trained infantryman can hit a man-sized target with a well-aimed shot from any standard infantry rifle. The decisive variable is fire volume. The side that generates more outgoing rounds per minute forces the other side into cover, degrades their ability to return accurate fire, and creates the conditions for maneuver. The arithmetic. A 12-man squad of M1 Garand riflemen, firing at a measured rate to maintain accuracy, produced approximately 96 rounds per minute of outgoing fire. A 12-man squad of Carabiner 98K riflemen, operating at the same measured pace, produced approximately 40 rounds per minute, 2.4 times the fire volume, from the same number of men, firing the same caliber ammunition. The German officer's testimony was, if anything, conservative. The German army understood the problem by 1942. Reports from the Eastern Front had made it clear Soviet infantry, equipped with semi-automatic SVT-40 rifles and PPSH-41 submachine guns, were generating fire volumes that German bolt-action squads could not match. In defensive positions, German MG-34 and MG-42 machine guns compensated for the deficit. In fluid engagements, on broken ground, in close terrain, the bolt-action infantry was at a structural disadvantage. The German response was the Gewehr 43, a semi-automatic rifle designed explicitly to match the M1 Garand's fire rate. It entered limited production in 1943. The word limited is doing significant work in that sentence. Germany produced approximately 400,000 Gewehr 43s during the war. The United States produced 5.4 million M1 Garands. The Gewehr 43 was also significantly more complex to manufacture than the Garand. It required more machining operations, tighter production controls, and components that were more difficult to produce under wartime conditions. As German manufacturing capacity came under increasing pressure from Allied strategic bombing, Gewehr 43 production became progressively less reliable in quality and consistency. The Americans had solved the manufacturing problem in 1936. The Germans tried to solve it in 1943. The difference in timing was not accidental. It was the difference between a military establishment that asked systems questions and one that asked doctrine questions. There is a dimension of the M1 Garand story that receives almost no attention in standard military histories. It is, in some ways, the most important dimension. The rifle's field maintenance system. A weapon that cannot be maintained in the field is not a weapon. It is a liability. The most accurate, fastest firing infantry rifle ever produced is tactically worthless if it requires a machine shop to repair. The M1 Garand was designed from the beginning with field serviceability as a primary specification, not an afterthought, not a secondary consideration, but a design requirement with the same priority as accuracy and reliability. The Garand disassembles into its major components without tools. Trigger group, stock, barrel, and receiver. 3 major assemblies, separated in under 30 seconds by a trained soldier. Each assembly is itself modular. A damaged trigger group can be replaced in the field in under a minute, using parts drawn from the same gauge-verified supply system that produced the rifle. No fitting, no adjustment. Pull the old assembly, insert the new one. Function check, ready to fight. This is what interchangeability means in practice, not a manufacturing abstraction. A soldier in a ditch in Belgium in November in the rain, replacing a damaged component in 2 minutes with cold hands and returning to the fight. Behind every production statistic in this story, there are human beings. At the peak of M1 Garand production in 1943, the Springfield Armory employed over 13,000 workers. Many of them were women brought into the manufacturing workforce because the men who had previously held those jobs were now the men firing the finished product in North Africa and Sicily and New Guinea. These workers operated precision machinery they had learned to use in weeks, held tolerances they had learned to verify with instruments, and produced components that met standards their instructors had been trained to enforce. One of those workers, a woman named Evelyn Gerber, documented in Armory employment records, worked the receiver inspection line from 1942 to 1945. In that period, by her own account, collected in a post-war oral history, she personally passed or rejected inspection on more than 100,000 receivers, each one measured against the gauge standard. Each decision made by hand, by eye, by calibrated instrument. She did not know where the rifles went. The Armory did not tell workers which units received which production batches. She knew only that she was making something that had to be right. And so she made it right. Every time, for 3 years. In January 1945, General George S. Patton wrote a letter to John Garand at the Springfield Armory. The letter is brief. It runs to 2 short paragraphs. Patton was not a man who wasted words. He wrote that the M1 Garand was, in his assessment, the greatest battle implement ever devised. Not the best rifle, the greatest battle implement. The language is precise and deliberate. Patton was not complimenting the weapon's craftsmanship or its mechanical ingenuity. He was making a systems observation. A battle implement is a tool whose value is measured by its contribution to battle outcomes, not by its elegance, not by its engineering sophistication, by what it produced when a soldier pointed it at an enemy and pulled the trigger. What it produced was fire superiority, consistently, reliably, in the hands of soldiers who had trained with it for weeks, not years, across climates that ranged from the jungles of the Pacific to the frozen forests of the Ardennes, through 3 years of combat operations that tested every assumption its designers had made. The M1 Garand did not fail. Not as a weapon, not as a manufacturing system, not as a maintenance problem. It performed exactly as specified, at exactly the scale required for the entire duration of the war.
Here is the thing that the standard history of the M1 Garand never reaches. The rifle was not decisive because it was the best semi-automatic infantry weapon of the war. It was not. The Soviet SVT-40 had comparable performance in controlled trials. The German Gewehr 43, in its best production runs, met or exceeded the Garand's mechanical specifications. The M1 Garand was decisive because it was the only semi-automatic infantry rifle in the war that was produced in sufficient quantity, to sufficient consistency, with sufficient field maintainability to function as a system rather than as a collection of individual weapons.
Quantity meant that every American infantryman carried one. Not most of them. Every one of them. The rifle was not an elite weapon distributed to designated marksmen. It was the standard issue weapon of the United States Army Infantry. From first day of training to last day of combat. Consistency meant that the doctrine built around it, the fire volumes calculated in training, the ammunition expenditure rates planned by logisticians, the maintenance schedules established by ordnance officers, were valid across the entire force. Not for some rifles, for all of them. Maintainability meant that the rifle could stay in the fight through conditions that disabled other weapons. Sand in North Africa, mud in Italy, cold in the Ardennes, salt water in the Pacific. The M1 Garand was designed to be cleaned with whatever was available and returned to service in the field. Because the designers had asked the right question. Not how do we make this rifle accurate, but how do we keep this rifle functioning? Systems questions. Again, in September 1945, as the United States demobilized, the Army Ordnance Department completed an assessment of M1 Garand production and performance across the war. The figures were as follows. Total rifles produced, 5,400,000. Total rifles condemned as unserviceable due to manufacturing defect across the entire war, fewer than 800. 800 rifles out of 5.4 million. A defect rate of 0.015%.
That figure, not the rifle's accuracy, not its fire rate, not the fire superiority it generated in combat, is the number that explains everything. It is the number that tells you what John Garand actually built, what Springfield Armory actually produced, what every inspector, every machinist, every worker who measured a part against a gauge standard and either passed it or rejected it actually contributed to. They built a system. And the system won. The German officer who told his interrogators that the American rifle was the most significant tactical advantage the American infantryman possessed was not wrong. He was simply describing the surface of a much deeper story. The rifle was the visible output. The system behind it, the gauge standards and the inspection lines and the interchangeable parts and the field maintenance protocols and the production contracts and the 14 years of bureaucratic struggle that John Garand endured to get his design approved. The system was the advantage. The lesson of the M1 Garand is not that semi-automatic fire wins firefights. That is a tactical observation. The lesson is that the side with the better system wins wars, and that building a better system requires asking a different set of questions. Not what is the best weapon we can design, but what is the best system we can build? John Garand asked that question. The Springfield Armory built the answer. And 5 million times, in 12-gauge verified manufacturing steps, a piece of steel met that answer's standard and became part of the weapon that redefined what an army could do. I am the arsenal files, and the systems are always deeper than the surface.